Hey there, cosmic enthusiasts. I'm Wise, and you're watching Wizard, where curiosity meets the cosmos. Can you guess what this is? I know it's a planet, but can you guess which one? No, it's not Uranus, it's Neptune. A team of scientists from the University of Oxford has recently concluded that our popular ideas about the colors of Uranus and Neptune are all wrong. Rather than being two distinct shades, they are, in fact, nearly the same shade of greenish-blue. I know we all love to see pictures and wallpapers of the colorful space, but a lot of this beauty would vanish if we could only see it with the naked eye. But the question is, why does NASA publish the color and pictures of these stars and planets like this? We are not only talking about planets and nebulas, but even the majority of the spectacular images of planets, stars, galaxies, and nebulae aren't much to look at through the eyepiece of a telescope. For example, Jupiter and Saturn look like disks. Now, let's talk about constellations. They are helpful in several ways. Navigation. Historically, constellations were used for navigation, helping sailors and travelers find their way by using stars as reference points. Calendars. Constellations were also used to track the seasons and create calendars, as the positions of certain constellations change throughout the year. Astronomy. In modern astronomy, constellations are used as a way to divide the sky into manageable sections, making it easier to locate and study celestial objects. Education. Constellations are often used in educational settings to teach people about the night sky and the basics of astronomy. Culture and mythology. Constellations have played a significant role in many cultures' mythology and storytelling, adding to their cultural significance. In astronomy, constellations are primarily used as a way to divide the celestial sphere into recognizable and manageable sections. Here are some ways constellations are used in astronomy. Locating celestial objects. Constellations are used as reference points to locate and identify stars, planets, galaxies, and other celestial objects in the night sky. By knowing the constellation a particular object is located in, astronomers can more easily find it using telescopes or star charts. Naming and cataloging. Constellations provide a convenient way to name and catalog stars. Each star is assigned a designation based on the constellation it is located in, along with a Greek letter to denote its relative brightness within that constellation, e.g., Alpha Centauri. Historical and cultural context. Constellations have historical and cultural significance, often reflecting myths, legends, and stories from various cultures. Understanding these cultural connections can enrich our appreciation of the night sky. Teaching and outreach. Constellations are commonly used in educational settings to teach people about the night sky and basic astronomy concepts. They serve as a visual aid for understanding the layout of stars and their movements. Research and observation. While constellations are not used extensively in modern astronomical research, they can still be useful for amateur astronomers and for certain types of observational studies that require knowledge of celestial coordinates. Overall, constellations provide a framework for understanding and navigating the night sky, connecting us to the vastness of the universe and inspiring curiosity about the cosmos. The Pleiades, which are also known as the Seven Sisters, Messier 45, and other names by different cultures, is an asterism and an open star cluster containing middle-aged stars in the northwest of the constellation Taurus. They are just a collection of points of light. Even galaxies look colorless, like color is drained from them. Nebulae, which we know are interstellar clouds of gas and dust, look like colorless blobs of mist. The real thing to understand is that the pictures of these nebulae we see are reconstructed colors, meaning these images will not reflect what we see with our naked eyes. The real reason so many images look so brilliant is that they have been enhanced in various ways. The simplest way is by using long exposure to draw in as much light as possible. This turns the Andromeda Galaxy from a mist into a giant whirlpool of stars and the Crab Nebula from a blob into a mini-filament, colorful leftover of a supernova. Another reason is that the human eye can only see wavelengths of ultraviolet rays. We cannot see infrared rays, which are different wavelengths of light. Under visible light, Venus looks like a dirty yellow ball of smog. Under infrared, the swirl of the clouds pops out. The same is true of images of Jupiter and Saturn collected by deep space probes and space telescopes. The naked eye reality may be dull, but by using different wavelengths, scientists tweaking the contrast and using colors to bring out otherwise hidden features, the results can be amazing, which makes it easy to understand and study them in further research. If you like this type of content, then don't forget to like, subscribe, and share the cosmic love. Now coming back to Uranus and Neptune. A team led by Professor Patrick Irwin found out that this misconception came from the images sent back by Voyager 2, the only spacecraft to visit both planets. These weren't direct color images, but composite images where the planet was photographed using 3 filters, one for red, one for blue, and one for green. Each of these images was black and white, but when they were recombined using the appropriate optical filters, they produced a full-color image. Unfortunately, these recombinations weren't balanced as well as they could be, and their results tended to come out a bit on the blue side, which was especially the case with Neptune. This was further exaggerated when the contrast on the Neptune images was dialed up to reveal the clouds, bands, and winds of the gas giant's atmosphere. By using data from Hubble Space Telescope Imaging Spectrograph, STEES, and the Multi-Unit Spectroscopic Explorer, MUSE, on the European Southern Observatory's Very Large Telescope, the Oxford team had full-spectrum light images of Uranus and Neptune that they could use to build computer models for comparison with the Voyager 2 images. This allowed them to rebalance the composite color images and show that Uranus and Neptune are a similar shade of greenish-blue, with Neptune coming off a tad more blue due to an extra layer of haze. Although the familiar Voyager 2 images of Uranus were published in a form closer to a true color, those of Neptune were, in fact, stretched and enhanced, and therefore made artificially too blue, said Irwin. Even though the artificially saturated color was known at the time among planetary scientists, and the images were released with captions explaining it, that distinction had become lost over time. Applying our model to the original data, we have been able to reconstitute the most accurate representation yet of the color of both Neptune and Uranus. To correct this misconception, the Oxford team used data from the Hubble Space Telescope and the European Southern Observatory's Very Large Telescope to create more accurate color models of Uranus and Neptune. They found that both planets are a similar shade of greenish-blue, with Neptune leaning slightly more blue due to an extra layer of haze in its atmosphere. This discovery highlights the importance of accurate data interpretation in scientific research and reminds us that the beauty of the cosmos often lies beyond what meets the eye. So, the next time you gaze up at the night sky, remember that what you see is just a glimpse of the vast and colorful universe that lies beyond. If you like this type of content, stay tuned for more. If you enjoyed this adventure, don't forget to hit like, subscribe, and share the lunar love. Until next time, this is Wise from Wizard signing off with a tip of the colorlessness.